for coming. My name is John Elbi. I'm partner CIO at Nahmani Grunder. We are a multifamily office in Switzerland. And it's a pleasure to have Andrew Feldman here. He's the founder and CEO of Cerebras. I was thinking how to set this whole discussion up, and I decided that I would just basically keep it quite simple and give you some numbers. We today, currently, post the launch of ChatGPT in November 2022, we're going through this massive, unprecedented build-out in AI infrastructure. And it all seems to be driven by the scaling law that was stated by OpenAI. I mean, the scaling laws of OpenAI basically imply that a 2x improvement in the performance of an LLM requires a 10x increase in compute power. And hence, it's not a surprise to see, for example, NVIDIA, their numbers, fiscal 23, which ended in January 23, they had revenues of 25 billion. Last fiscal year, revenues grew from 25 to 60 billion in a year. At that scale, 130% growth year over year in revenues. And in fiscal 25, those revenues are forecasted to grow to more than 100 billion. So within 2 years, this company will have gone from 25 billion in revenues to more than, close to 110 billion of revenues, with gross margins of 77%, which are unheard of in the semiconductor industry, and free cash flow margins of 50%, with all these numbers being driven through their vertically integrated full stack solution. Obviously, I know they're benefiting from this unprecedented demand, but there are other solutions out there in the market. And hence, I think it's great to have Andrew here, and it's very timely to talk about other approaches to the same problem. But I thought we would first play your video, no? Or how should we do this?
First, thank you for having me and for introducing one of the few companies growing faster than NVIDIA. Thanks for inviting me to talk today. But apparently, as we grow quickly, our marketing team has submitted a video.
Let's do that.
Let's play a video.
From our shared vision, we at Cerebras came together to build what many thought was unimaginable. Our goal was to create the largest and fastest AI chip in the world. Wafer scale integration was once deemed impossible. We at Cerebras made the impossible a reality. We designed the largest chip in the history of the compute industry. It's a testament to our ambition, to our ingenuity, and a relentless work ethic. Our chip now powers supercomputers pushing the limits of AI. Not just a tool, it's a catalyst for progress, empowering industries, science, and innovation around the world. At Cerebras, we're not just shaping the future of AI, we're inspiring a new generation to continue to imagine, to innovate, to inspire, to do work other people say is impossible. Together, we can push the limits of what's possible.
Wow.
Are you happy with that?
Well, two things. I think we know for sure I don't have a future as a voiceover artist. But yeah, we build AI systems, and we begin with a wafer scale chip, the largest chip ever built, and using a technology everybody said could never be built. Our chip is 46,000 square millimeters, so it's the size of a dinner plate, whereas others are the size of a postage stamp. We add those into a system that we designed. We tie those systems together into supercomputers, and then we train some of the largest AI models on them. It's been an extraordinary run, and that's what we do.
Andrew, just to start off before we start making comparisons, can you just talk to us about the story of how you started the company and why you decided from the beginning to focus on more specialized AI chips than more general purpose chips?
Sure. This is my fifth startup. We took one public and we sold 3. All the founders worked with me at our last startup, a company called C Micro that AMD bought in 2012. We got together in mid-2015, and we wrote two things on the whiteboard. We said we wanted to work together again, and that we wanted to move an industry we cared about. And as computer architects, what we do is we ask ourselves a very simple question. Is there an interesting workload on the horizon? And can we build a better machine to do that work? And we saw AI on the horizon, and we came to believe, after extensive study, that we could build a better machine for AI work. And in the beginning of 2016, we went out, gathered an extraordinary consortium of investors, and began this amazing adventure.
Can you just talk to us about your approach, which is very different? So the whole wafer scale engine, that the whole wafer is the product, and compare that to NVIDIA's H100.
Sure. Our latest wafer is a 5 nanometer part. It has 4 trillion transistors. The largest NVIDIA part has 80 billion transistors. So we're order 55, 60 times larger. We solved a series of problems in the design, development, manufacture of semiconductors that had never been solved in the 75-year history of the computer industry. And we attacked this particular class of problems not because we're gluttons for punishment, but because AI work has a very, very particular set of characteristics. The actual compute work done in AI is almost trivial. It's mostly multiply and accumulate. It means we're mostly adding and subtracting, and in particular, we're doing large matrix multiplies. What's really hard about this work is the communication pattern. We do work, and we move the results. And we do work, and we move the results. And it's this moving that is punishingly difficult. And in 2016, as we were thinking about how to attack that part of the problem, we came to believe that if we could keep the work on a big chip, we would have to move it less. When you move work on a chip, it's about 10,000 times faster than when you move it off a chip, and about 1/10,000th the power draw. So by having a big chip, we could keep information on the chip, we could do work faster, we could do it for less power. Now, the importance, obviously, of moving data wasn't lost on NVIDIA. What did they do? They spent $7 billion on Mellanox to build a fabric that would enable them to move data. But they still divide up the wafer into little pieces. Yeah. They spread it out over thousands of little chips. And then they ask the ML practitioner to distribute their work across this ocean of processors. That's an extraordinarily difficult challenge. So, for example, if you look at the back of OpenAI's GPT-4 paper, they thank 100 people for helping distribute compute, helping take the model, put it over the thousands of GPUs. We do that work in about 45 minutes with one person. And that's because we have a really big chip. We don't need to do that type of distributed computation. So by choosing to go big, by choosing to solve a set of problems that everybody said couldn't be solved, we were hundreds of times faster and at a tiny fraction of the complexity of doing the AI work.
So effectively, you both manufacture at TSMC these wafers that NVIDIA gets are cut into smaller chips, and then they're again interconnected through NVLink, and then the whole InfiniBand.
More things they make,
yeah.
Right? Exactly.
So you're
Through
basically
switches.
cutting them through, but bringing them together again, whereas you just never go through that process, and that's why you're much faster.
That's right. I think it's a Humpty Dumpty where everybody begins on a wafer, and almost everybody else cuts up the wafer into little pieces, and then asks you to buy new things to tie those pieces together again. And we don't. We keep the work on the big wafer. And if you want to see one, I brought one here. We can share it to you after the talk. And that gives you tremendous advantages.
If you listen to Jensen, I mean, the big pitch is, we are a full stack solution, and CUDA is the big differentiator because it's a unifying compiler, allows third-party developers to access this huge installed base of GPUs that are out there. So, I mean, you're faster, but how much of a differentiator is CUDA and their compiler?
I get asked this question a lot, and it's really important. I encourage you to go to your organizations and ask the ML practitioners and the AI practitioners if they ever write in CUDA. And the answer is none of them do. And that what has happened is that PyTorch has become the language of the ML practitioner. And PyTorch allows, not just us, but it allowed Facebook, who designed it, and Google and everybody else to make models and make them fully portable across different types of hardware. And not without, so no intention of sort of disparaging the end-to-end full-stack solution. We're a full-stack solution. We didn't believe the right way was to be a chip company here. It was to be a system company. But I don't think CUDA is the heart of their advantage. And I think every major hyperscaler and every major open source company is working against CUDA. They're working on PyTorch. They're working on ensuring that any model written can be brought to our hardware, to the GPU, to the TPU, to whatever Amazon's making, to an entire range, to AMD's GPU. All of those are designed so that you can have portability across models.
You seem to be focused on training primarily for now. How does this look as the market moves increasingly to inference, especially on-device inference?
So a couple things. I think for the first several years of AI, we were sort of in the world of hobbies. We were training models. We were excited at how they trained, but we hadn't moved them into production. And when you move a model into production, it moves to being served, and that's doing inference. Now, we built a system, and we first targeted training. And then we began working on a very particular type of inference for the military and the intelligence community. And those were the hardest inference problems. Those are inference problems where you need real-time results. Over the last year, we've seen the rise of production AI. That means AI going to being served, being the back end of applications. And we've seen the compute demands from inference spike. I think you'll hear from us a collection of partnerships in the next months, as well as new technologies that will attack that part of the market as well.
Including a specific company based in San Diego.
We will have a partnership with others who make inference products for governments, militaries, and consumers as well, for sure.
You've announced a dozen of major customers across enterprise, federal, sovereign nation states. Can you just talk about how basically these people are using Cerebras technology today?
Sure. Recently, we announced a partnership with Mayo Clinics, right? The premier medical institution in the US and maybe the world. They have extraordinary medical data. And we are working with them to train models on a range of different techniques to help the medical professional. Some of them where we look at genetic information and attempt to predict which rheumatoid arthritis drug will have most efficacy. Today, rheumatoid arthritis drugs are sort of hit and miss, and sort of you try them for 6 months, and if they don't work, you try another one. We're looking to see if we can find genetic predispositions for success. We also, in our partnership, achieved HIPAA compliance. So we have patient record data, and we're doing AI on patient files. We're looking at their image database of radiology, pathology, dermatology, all right, building medical assistants for doctors. In working with GlaxoSmithKline, we have been working over the last several years, both with equipment on their premise and equipment in our cloud to accelerate drug design. We've done epigenomic work, we're doing drug design work, binding site affinity work, all with the head of AI and analytics at GSK. In the Middle East, we work with a customer called G42, and with them we trained the largest Arabic LLM in the world. This is the most effective and highest accuracy Arabic language model. There are 400 million Arabic speakers, and there wasn't a good way for them to enter an LLM. So we trained the model with our partner. Microsoft now serves it, and it is the heart of their Middle Eastern offering. I mean, I can go on for days.
Why don't you talk about oil and gas, maybe as the last example?
Sure. We have done work both with Total, the French supermajor, in both AI and in HPC-style work, in which we were able to radically accelerate oil field modeling and harvesting. We had a similar project with Kaust in Saudi, where what they showed was that in working with 48 of our machines, they were able to do work faster than any supercomputer on Earth. And so whether it's in pharma or life sciences or startups, whether it's oil and gas, whether it's sovereign clouds, we're building interesting AI models to solve real problems.
Can you talk to us a bit about your financials? There's a lot of customer momentum. So revenues, backlog, maybe pricing as well, if you can.
So we had a good year last year. We were up 10x. We booked more than $250 million. Manufacturing, we increased manufacturing throughput more than 10x. We had a massive backlog when we entered the year. Our expectations are extraordinary for the year. I think we will be at every stage of the year supply constrained, even if we increase manufacturing 10x again. There is an extraordinary demand, and I think it comes from places that aren't top of mind always for US investors. We get asked frequently about the US hyperscalers. The government of Saudi Arabia will do vastly more than AWS, without question. The Middle East right now is booming. Sovereign clouds are extraordinarily interesting, and huge money is being put to work there. Companies that you might not have heard of, might not be on top of mind, are going to drop 10 and 11 figures in single transactions for AI hardware. And so it's a landscape that's very different from where we might have been 8 or 10 years ago, where if you weren't at the 4 or 5 hyperscalers and maybe in the IT world, a handful of big commercial banks, you were in tier 2. There are players in the Middle East who are going to buy more than any of those combined.
It's just if you look at H100, it's priced at $40,000. They have gross margins of over 80%. So how do you price your product?
Margins are higher than 80. I think they're pushing them down.
So for example, the specific product that you're just now, I think you have the first sample for G42, 100 million. How do you price that? Can you just talk a bit about that?
Oh, we'll do much more with them. That was the first order. We've stood up for them in the past 6 months, 8 exaflops of compute. The largest supercomputer in the US, owned by Department of Energy at Argonne National Labs, and another one at Oak Ridge National Labs, is 2 exaflops. So we're standing up an extraordinary amount of compute for that customer. We've based it in the US. We've just started another system that will stand up that will be another 8 exaflops. Yeah, we're putting up enough to change the worldwide inventory of compute.
So where is all this going? I mean, you have CSPs
up and to the right, John. Up and to the right. It's going up and to the right.
How much to the right? So the question is, you have CSPs.
I've run out of paper. That's how far up and to the right we're going.
Well, you have CSPs going through this arms race. Consumer internet companies, Meta was, I believe, the largest customer for NVIDIA last year. Sovereign AI has come now. So this compute build-out, how big can it get, do you think? How do you see that?
I don't see an end. And I think people who say they can see more 2 or 3 years in the future in our space you ought to question them carefully. But I see no end in the next 2 or 3 years. I think NVIDIA announced they would be supply constrained for at least the next year.
Yep.
I think we and everyone in our supply chain agrees that there is no end in sight if, as far as you can see, is 2 or 3 years.
But NVIDIA is supply constrained, but so are all the HBM suppliers. So just tell us.
We don't use HBM. We made some very thoughtful decisions.
So that's what I wanted to get.
We stayed away from SerDes, so we didn't pay a tax to Broadcom. We stayed away from HBM, so weren't constrained there. We didn't use an interposer, which is actually the thing that's constraining NVIDIA right now. NVIDIA's solution uses 2 chips. It uses a chip at 4 nanometer and a chip at 65. The 65 is basically a carrier for the chip at 5. It turned out that they overwhelmed the demand on the trailing edge fab and can't get those fast enough, and that's what's limiting supply. We didn't do that. We were able to stay on 5. We're building on 5 now. We don't use many of the parts that were in their supply chain, and so we were able to avoid that. We've been able to meet our customer needs.
What you do use, similar to them, is TSMC as a manufacturer. I think they're on 4 nanometer. You're just switching down to 5.
There are not a lot of choices. I don't know if you guys stay sort of with your nose to the grindstone with regard to fabs, but if you want to be at an aggressive fab geometry, there are only 2 choices in the world. You're either at Samsung or you're at TSMC. And we're at TSMC. We've been at TSMC over 3 generations. We began in 2019 at 16, and end of 21, we went to 7, and now we're at 5. So there aren't any other choices anywhere in the world. And so we are there. TSMC is an extraordinary company. They are very comfortable making room for smaller companies. I think they could, if they wanted to, give all their supply to Apple and Qualcomm and NVIDIA and AMD. But they also know that then they have no new customers. And so Apple wasn't able to make chips until they acquired a company called PA Semi, who was making a very small number of chips from TSMC. And Apple and TSMC work together. Now they're Apple's largest customer. Now TSMC is the provider for Apple, and Apple's TSMC's largest customer. That came through an acquisition of a very small company.
Sure.
And so they've had a strategic strategy to enable smaller companies to ensure access to supply of wafers. And we're doing okay with them.
Just maybe last then, because I'm fascinated by this. If you look at the whole supply chain, ASML is a monopoly.
Own their stock.
TSMC, it's pretty much a duopoly. And then you currently have NVIDIA plus AMD trying to catch up, and Intel with Gaudi 2. Let's see if that works. But we need more choice as this massive build-out is going to continue, as you said. We were talking this morning. I mean, your cash break even. You raised your last round in 2021. Maybe just as we finish this session, what is the roadmap for Cerebras and for investors?
I think we've raised over $750 million. We are cash flow break even. We are coming off a 10x year. Don't see many of those in your career, do you? And growth is not slowing down. I think we will deploy hundreds and hundreds of exaflops. We might even get to a deployed zettaflop in the remainder of the year. I think we will train models that change the industry. And I think we don't need to take share from NVIDIA. We are in a universe that is expanding at a rate we've never seen before. And I think they will continue to do extraordinarily well, as will others. I like AMD. Lisa bought my last company, and we have great respect for the work they're doing there. They'll do well too. But I think the universe here is expanding at such an extraordinary rate that there'll be many, many winners. And I think there'll be some eye-popping numbers and some eye-popping supercomputers put up in the next 12 months. I think what used to be the norm, right? You used to say that no company could add $40 billion in revenue in a year. I think you'll see in software companies some extraordinary numbers. And I think in other system companies like ourselves, you'll see some eye-popping growth as well.
Andrew, we've run out of time.
That was fast.
But that was fast, but fascinating. Thank you very much.
Thank you guys for paying attention.